Hello everyone, this is Mr. D'Agostino. This is Unit 11, Lesson 2 Startup. Itinerary for today. Do now problems, pause video, and do problems on your own. When you are finished with the problems, unpause the video and watch me go over them. Number 2, Family Feud question of the day. Pause the video and write down answers. Unpause the video when you are ready to hear the answers. Number 3, go over the last lesson's homework. Number 4, watch next lesson for math instruction. You have 2 do now problems. Number 1, number 39 for my JMAP file. Number 2, number 137 from my regions file. Alright, go ahead and pause the video and try these 2. Alright, the first question. Julie deposits $2,000 into a savings account that earns 4% interest per year. The exponential function that models this savings account is y equals 2,000 times 0.04 raised to the t, where t is in time, whereas t is the time in years. That's very, very important. That kind of made me, that will make you understand the problem and get the answer correct. Very, very important. You'll see in a second when I go over it. Which equation correctly represents the amount of money in her savings account in terms of monthly growth rate? Now, this 1.04, that's your 1 plus r. That's in terms of a year, every year. So we have to work backwards to get it to monthly growth rate. So what you do is you take your 1.04 and you raise it to, now we're going to go back monthly, so that's 12 months in a year. So you're going to raise that to 1 over 12. So now what this gives you, it gives you every month this is what you're making. Now, first I looked, the answer was 3, which 3 or 4, which basically, using process elimination, I'm down to 3 or 4. Now I was asking myself, all right, if t is every year, so what this means is if t is 1 year, what I'm doing here is I'm raising this up to 12, and that gets you back to the 1.04. So now in my mind, I'm thinking every year is t. So if I want to put 2 in here, then that really means 24 months worth of interest at the monthly rate. So that makes sense. Now you never change the initial. I know in choice 4 and choice 1 they were changing the initial investment. That never changes. That stays the same. So the answer is choice 3. All right, number 2, pretty easy question. Which statement are true for all real numbers? Now, you guys know that when you write this twice, you're going to get a trinomial. And you're going to have some middle term here. You never do x to the second, y to the second. It never really works. You don't do that. That's not how it works. You've conditioned to know anytime you have a binomial squared, you write it twice and you FOIL it out. All the time, it's going to give you a trinomial. You get a binomial. Now you can also plug numbers in for x and y and see if it works. If I plug 3 in for x, and 4 in for y, and I plug it in, 3 minus 4 squared is not going to be the same thing as 3 squared plus 4 squared. It's definitely not the same. Same thing with 2. If you plug in 3 and 4 in, it's not going to give you the same. Again, the same thing, You might think, oh, you know what? There is a middle term here, but you have to write this 3 times and FOIL it out, or use the box method. So this actually doesn't work either. So if you plug these numbers in, 3 plus 4 to the third, which is basically 7 to the third, is that the same thing as 7? Sorry, is that the same thing as? The same thing as 3 to the third plus 4 to the third plus 3 times 4? And absolutely not. It's not going to be the same. So it's actually neither. You can always use a calculator to verify that. But 7 to the third is not going to be the same thing as 3 to the third plus 4 to the third plus 3 times 4. All right. If you want, let's use the calculators to verify that. So 7 to the third is 343. 3 to the third plus 4 to the third, which is the x to the third and y to the third, plus 3 times 4. If it was the same, then possibly, because when you try to prove something, one example will not suffice, so you have to actually use multiple x and y values to plug in. But to disprove something, all it takes is one example. In this case, we did that. One example disproves it. So neither 1 nor 2 will be true. Let's take a look at the homework from lesson 1. Rotations and angle terminology. So the question is, we want to draw the rotation diagram and then state what quadrant it terminates in. Now we know that a full circle is 360, so if I want to know where this angle terminates, you always start on the x-axis, the positive x-axis, and you go counterclockwise direction. So here's your terminal ray. Okay, so they're asking you, where does the terminal ray end? Your terminal ray is where the angle ends. So if you're going 135, this is 0. That's 0. This is 90. This is 180. This is 270, and this is back to 360. And you keep on going if you want. 135 terminates in the second quadrant. This is 90. This is 180. So it's pretty much in the middle. So that's considered a coterminal angle. Okay, 135, and then another angle that terminates in the same spot is they're called coterminal angles. 300. This is 90, 180, 270. So 300 is right here. Again, it's counterclockwise. It terminates in the fourth quadrant. Right, this is quadrant 1. Do a different color here. Let's do what color you want. I like green, so let's go with green. So this is quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. So it terminates in quadrant 4. Again, it's counterclockwise. All right, now what I like to do, this is showing that it's going clockwise because it's negative, which is true. What I like to do is anytime I have a negative angle, I always add 360 to it. Because what I'm doing is I'm producing a coterminal angle. So that gives me 250. So if I go 250 counterclockwise, this is 90, this is 180, this is 270, this is 250. So negative 110 and 250 are considered coterminal angles. But since it's negative, you go this way. clockwise. This is negative 90, this is negative 110. So negative 110 and 250 are coterminal angles. All right, D, again, we have a negative angle, so I'm going to add 360 to it. So negative 10 and 360 gives me 50. So 50 and negative 310 are considered coterminal angles because they terminate in the same spot. So here, this is 50 also, this way. But since it's negative, they want you to show the diagram going counterclockwise rather than counterclockwise. 85 is in the first quadrant. Now, when you have an angle that's greater than 360 and you want to figure out its coterminal angle that's between 0 and 360, you subtract 360. So 560 minus 360 gives you 200. So 200 is considered a coterminal angle. So if you go just one rotation around, this is 90, 180, 200, it's going to terminate in the same spot. So going one full circle is 360, then another 90 is 450, another 90 is 540, and then another 20 is 560. So one full circle and then getting to 560 is the same thing as going just a 200. So 200 and 560 are considered coterminal angles. For each of the following angles, drawing a rotation diagram determines reference angle. All right, a reference angle is an angle that's between 0 and 90, basically a positive acute angle. And it always forms the terminal side of the angle and the x-axis. So this is considered your reference angle. So if I have an angle of 245, my reference angle is going to be 245 minus 180, which in this case is 65. So if you're in the third quadrant, you want to find your reference angle. It's going to be angle minus 180. So if I want the reference angle, my notation for reference angle is theta r. So reference angle, or in this case, they're using this notation, which is alpha or alpha r, depending on what symbol you want to use. So third quadrant is going to be angle minus 180 to get the reference angle. All right, 290 is in the fourth quadrant. So this is your reference angle. So my reference angle is going to be this whole circle, which is 360, minus angle. So my reference angle is going to be 360 minus 290, which in this case is 70. So if I want to find my reference angle in the fourth quadrant, it's 360 minus the angle. All right, if my angle is 130, if I'm in the second quadrant, it's just 180 minus angle, which is my reference angle. So 180 minus 130 is 50. So 50 would be my reference angle. So if I'm in the second quadrant, it's angle minus angle, 180 minus angle. If I'm in the third quadrant, it's angle minus 180. If I'm in the fourth quadrant, it's 360 minus angle. Now, if my angle is not between 0 and 360, what I do first is find an angle that's between 0 and 360. Now, if my angle is negative, you add 360 to it. So what is negative 242 plus 360? What is that, 118? So that gives me 118, right? Now, 118 is in the second quadrant. How do you find the reference angle in the second quadrant? 180 minus 118. So 180 minus 118 is 62. If I have an angle that's bigger than 360, I subtract 360 to find a coterminal angle, which is 115. which again is in the second quadrant. So I got to do 180 minus 115, which gives me 65. So if I'm on the second quadrant, it's 180 minus the angle. All right, F, we have an angle that's negative. Now look what happens when we add 360 to this. If I add 360, I get 72, negative 72. The problem with that, it's still negative. So what you do is you keep on adding 360 until you have a positive angle between 0 and 360. I'm going to add 360 to that. And what does that give us? That gives us 288. All right, 288 is in the fourth quadrant. So I'm going to do 360 minus 288, which gives us 72. So 72 is going to be our reference angle. So let me just recap what I did here. Let's see. Let's see what I did. I added 360 until I got an angle that's positive between 0 and 360. So when I added 360 the first time, I got negative 72. I added 360 again and I got 288. That's in the fourth quadrant. To find my reference angle in the fourth quadrant, I subtract. I add 360 to that. Sorry, if I'm in the fourth quadrant and I have an angle of 288, I subtract my angle into 360. So 360 minus the angle, which gave me 72. Got a couple of visitors here. We got Ryan, who's watching something on his iPad. We got Ava here.
Hi.
Making a video. She's going back doing her own work. All right, number 3. Give two angles that are coterminal with each of the following angles. Make one of the coterminal angles positive and one negative. Now, before, when we had an angle that was bigger than 360 or negative, I added 360 if it was negative, and I subtracted 360 if it was bigger than 360. Here, if I want a positive angle, that's a coterminal angle, I just add 360. If I want a negative, I just subtract. So that's why in this case I took 108 and added 360, gives you 465, and then take the 180 and subtract 360, gives you negative 255. So these are coterminal angles. Again, coterminal angles are angles that terminate in the same spot. All right, 220, add 360 and then subtract 360. 80, add 360, subtract 360. Now, if the angle's already negative, I can add 360, and then I can subtract 3, just that this is going to be even more negative. All right, that was number 3. Number 4, when drawn in standard position, which of the following angles is a coterminal angle to one that measures 130? Now, one of two things you can do. You can take 130 and add 360 and subtract 360 and see if that gives you one of the choices. So that's what I did here. Add 360 got you 490. But if I subtract 360, I do not get negative 70, so it can't be negative. So that means you can add 360 again. You can keep on adding 360 to generate as many coterminal angles as you want. So if I add 360 one more time, I get 850, which is one of the choices. So you can keep on adding 360 as many times as you want to get it, as many coterminal angles as you want. Number 5, which of the following angles when drawn in standard position would not be coterminal with an angle that measures 270? So if I add 360, I get 630. If I subtract 360, got negative 90. I took 630 and add 360 again, got 990. So negative 90, 630, 990 are all coterminal angles. So one that's not is 720. If you want, you could take the choices and add or subtract 360 and see if you get 270. That's another way of doing it. All right, number 6, which of the following angles would not have a reference angle equal to 30? Now remember, how do you get your reference angle? You take your angle depending on what quadrant it's in. Let's go through that again. Let's see. All right, so if I take 210, which is in the third quadrant, it's going to be angle minus 180, which is 30. The question is, which one will not have it, though? That one will have it. 120 is in the second quadrant, so you take the angle, so you take the 180 minus the angle, which gives us 60. That looks like that's the answer. Now, these are both negative, so what I would do is I would add 360 to both of these to get a positive coterminal angle between 0 and 360. So that gives me 30, and that gives me 330. Now, since this is in the first quadrant, 30 is its own reference angle. So that's its own reference angle. Now, in the fourth quadrant, you do 360 minus the angle to get the reference angle, which is 30. So the answer is choice 3. All right, number 7. Angles are a measurement of rotation about a point. Are two coterminal angles the same rotation? Explain your answer. Diagrams are helpful. Coterminal angles are not the same rotation. Rotations imply movement from one ray to another. For example, angles 90 and negative 270 are coterminal, yet a rotation of 90 represent a quarter term in a counterclockwise direction. So if it's a positive angle, it's going to go in the counterclockwise direction, counterclockwise rotation. Negative 270, since it's a negative, it's going to go in the clockwise rotation. So they might terminate in the same spot, but they do not have the same rotation. All right, this has been your startup for lesson 2. Ryan, you want to say hi? Ryan, hey buddy, you want to say hi to my class? Say hi, class.
Hi.
Say hopefully everybody's doing well. Tell everybody that hopefully everybody's doing well.
Hope you're doing well.
All right, guys, take it easy, and I'll see you around with the next video.